Alright, time for another draft. Physics.com, debatephysics.com also. Video presentation. So I just had a thought regarding the free momentum experiment. So I thought, what the hell? I'll throw it out there. Because I was observing that, when Dispar does this experiment, he puts the energy in, the heavy object gains momentum, free momentum, and then this reflection is huge. 80% of the energy comes back the other way. And I'm saying, well, why not just create a mechanism so you can just throw it back again and hit it again? And then throw it back again, hit it again. Since it's always going much faster than the heavy object. So the experiment, I guess, would look something like this. So he's apparently got a 10 mass versus a 1 mass that goes in. Okay, so you have a 10 to 1 relationship. And the idea would be is just do this. Instead of creating the velocity by pushing the car, just compress a spring that's against a wall. And now just let it go. And so the idea would be is the 1 mass would plow into the big heavy 10 mass. The big heavy 10 mass will go very slowly. So it's only going to be 1/10 of the velocity. Okay. I think in their case, it might have been 1/8 or something, because they're making free momentum, so it's going a little faster than the 1/10. So the idea would be is this would reflex, okay, with something. Oh, let's see. So if this is 1/8, all right. Let's say this comes back with. It's more than half, so 1 to 1.5, something like that. So 1 to some other, some decimal. Anyway, so it's still going pretty fast. So the idea would be is this is going very slowly. Okay, small vector. This is going very fast. Okay, so it would hit. Give it the free momentum, some portion of free momentum. Let's just say, for the sake of argument, 150% of the momentum goes into this object. All right, then it goes back and it comes back again because it's still got like 75% of its starting energy, and so it hits again and gives it, another 150% of the 75. So if we just called it a momentum number, we just said it was 150 the first time, it might only be 90 the second time it hits. And then it will probably have plenty of time, because this is going so much slower, that it can do a third hit, and that one might only give 30%, and the next hit might only give 10. So you could get 4 hits out of it anyway. So this would go back and forth. This is a short distance, and this is a very slow velocity. So this can do this 3 or 4 or 5 times before this has gotten far enough away that it's too far away for this to give it any more momentum, or it's slowed down so much that it doesn't matter. So you can't get any more speed into it because it's slowing down faster than you can put energy back in. So that's a huge flaw. So he'll have to do something different with his little cart, because his cart runs out of energy precipitously fast. Okay, it dies incredibly quickly. So in a very short amount of time and distance, and so that would be a downside. So the sled for the 10 mass has to be really frictionless, and for this to happen. But theoretically, okay, with an air cart or some other kind of thing, something more, there's only so many ways to do these kind of experiments. I mean, those CO2 pucks look pretty efficient, but again, that's another one of these things where who knows if they do tilt at all. But they used to use those back in the 50s. They used to have to spend some more money on an experiment than they do now. I guess they ran on dry ice, which was a real limitation. But I wonder if they could do it with like a CO2 cartridge. Yeah, I don't know. Yeah, it might be too erratic. But anyway, So, I mean, the point is that you could probably get up to a number, of 200 or 300 increase in the momentum if you can, because you're hitting it more than once. And this goes back to my argument about the magical anvil argument, where you can create a glass ball and hit an anvil and it will bounce, 200 times. So 200 times it'll go up and down on the anvil. And their theory is with each impact, it gave the Earth momentum. I'm saying no, that doesn't happen. And why not just make it so the anvil's on some sort of sled, that is very frictionless, and then we could just watch the anvil absorb the energy instead of watching the Earth absorb the energy. So some sort of idea where you suspend the anvil with a pendulum or something like that, and then hit it, 200 times. And see how much momentum you put into the anvil, because like by their theory you should be able to create at least 10 times the momentum in the anvil. So a huge increase in the energy. And again, if you just smash the anvil into a lever, you should be able to get back a higher velocity, put the energy back into a form that's more usable. So, I just don't, I think it's another argument against the plausibility of this theory that, you can put more momentum into an object. You can hit an object and put more momentum into it. It's physics. That's what they say is the truth. I'm just saying it's not. If it's possible, then I can't believe in, the hundreds of years they've been talking this crap, that nobody's been able to take advantage of free momentum. I mean, they can't find a device that can take advantage of free momentum. Hard to believe. All right, it's impossible to believe, really. I think it's beyond credible belief, and it will remain that way forever, and such. So, short video. One point to be made, and such.